Standard 1.10. Find the sine or cosine of an angle given a point on its terminal ray. All right, let's take a sketch of an angle, theta, and in this particular problem, let's put theta in the fourth quadrant. And we don't really care how big theta is, but let's take a point on our terminal ray. And let's say that the coordinates for this point are 2, negative 5. And our job is to find the sine of theta and find the cosine of theta. So the definition for sine of theta is y over r, where y is the y coordinate of the point and r is the radius of this circle if we were to draw that circle in, but you don't have to draw that circle in. And the definition of cosine of theta is x over r. And again, x is the x coordinate of our point, r is the radius of that circle. We have x, we have y, we need to find r. So the relationship between x, y, and r is the following. X squared plus y squared equals r squared. Let's use that relationship to find r. X is 2, y is negative 5, and by substituting we get the following equation. 2 squared is 4. Negative 5 squared is positive 25. Make sure that if you type in negative 5 squared on your calculator, you put negative 5 in parentheses so your calculator gives you a positive output. Equals r squared. R squared equals 29. And r, which is always positive, is equal to the square root of 29. So now let's use this value of r along with the x value of 2 and the y value of negative 5 to find the sine and cosine of theta. Okay. To review, sine of theta is equal to y over r. Y is negative 5. R is square root of 29. Now you can keep it in this form, but it's not considered simplified because you have a square root in the denominator. So multiply the numerator and the denominator by square root of 29. We call that rationalizing the denominator. And when you multiply across, your numerator is negative 5 square root of 29, and your denominator is just plain old 29. And again, this is equal to sine of theta in simplified form. Similarly, we can find the cosine of theta. Cosine of theta is defined as x over r. X is 2 and r is the square root of 29. Again, we can rationalize. It will be accepted in unsimplified form, but we want to be as sophisticated as possible as mathematicians here. And so we get 2 square root of 29 over 29 for the cosine of theta. And that was standard 1.10, finding the sine of theta and cosine theta from a point on the terminal ray. Again, keep in mind sine and cosine are just ratios. That's all it is, the ratio of two numbers, y over r for sine and x over r for cosine.